universe is made up of one thing surely is radiation and waves. And
Ma'am,
then, yes,
ma'am, maybe this shows a balance between positive and negative, like the
maybe,
waves.
okay,
The one
okay,
side is dark and the other side is white. And
okay, okay. And next artist is this Alicia Hunsicker, and she's also calling this cosmos. So what is she trying to depict? What about cosmos is she trying to depict?
Also a wave pattern, but sometimes it's superimposed to each other. I think so.
Okay, and what are other things apart
Interaction,
from waves?
ma'am, interaction
Uh-huh.
between particles. Interaction between particles.
Yes. So maybe she's trying to say that the cosmos is made up of two entities. One is matter and the other is radiation or waves. And the cosmos is a result of interaction between these, right? So there is so much of physics and in their artistic creations. And maybe they are physicists who have turned into artists, God knows. But beautiful creations, isn't it? But do you think that there is some similarity in the process of art and the way scientists or physicists think? When these people might have created these artworks, what is the first thing they might have started with, begun with? Supposing today you might have wanted to depict cosmos, how would you have gone about it? What would you have done? What is the first thing you might have done?
Oh,
Yes.
ma'am, we could go for fractals. Simple, but they keep repeating from miniature to,
So how did you think of fractals?
ma'am, because they keep repeating at any size and all of that.
That's fine. There are so many other things that keep repeating. And how did you even know about fractals?
Uh, it's a thing I had a fascination about. So
That's true. But from where did this fascination begin?
when observing the world,
Observing the world. So, do you think artists also observe the world very carefully?
yes,
Yes, ma'am.
And do you think scientists and physicists also observe the world very carefully?
yes, ma'am,
Okay. And after observing the world, what do the artists do?
ma'am, depict it from what they see from their point of view,
But they must be seeing so many things. I mean,
what they can
after
interpret.
all, you see so many things all around you. So, what do you do then?
Whatever they interpret, they put it in the form of art.
Yeah, but there is so many things that they must be interpreting. So can they put everything in one art?
No, ma'am.
So how do they go about it? First they observe and then what do they must be doing? They must be
Ma'am.
selecting what they want to pursue further, isn't it?
Yes,
like
ma'am.
the art first artist must have seen infinite nature of cosmos. He must have seen so many stars. He might have seen spiral galaxies. He might have seen waves, but at one time he decided to choose one feature and then think what about that particular feature, what are the characteristics of that feature. So do you think scientists or physicists also do something like that?
Yes, ma'am.
Yeah. So what is that they might be doing after observing?
They select a particular field or subject or
Yes,
topic they
a
further want to pursue.
particular, absolutely. They look at a phenomena which interests them more than anything else. And then they see what are the different features of that phenomena as the artist study. And then artists might select one characteristic out of many of those characteristics or features of that particular object or item they've selected. And same way scientists also do that. So you see, the artist as well as scientists, Both begin with minute observation and then research. Then they analyze and then they identify key features, whether artists or whether scientists or whether physicists. And then they select a particular feature, and scientists would select a particular phenomena, and then they conceptualize an idea. The scientist would The artist would conceptualize an idea, and the physicist probably would conceptualize the experimentation. And then the artist would select suitable medium and material, and a physicist would select the variables that he wants to study, and then the equipment required for doing some experimentation using those variables and the materials. And then artists would design the artwork, and physicists would design the procedure of the experiment. And artists would explore whether it would look this way or it would look good that way, or if this material is not working, I should take, instead of, let's say, bamboo, I could take some other material, maybe cardboard. And he would experiment that whichever material will bring out the best what he wants to represent. And same way physicists would explore and do experimentation and see the result. If it doesn't work out, he might improvise upon it. And then the final creation by the artist, or the final output and result and conclusion by the physicist, right? So there is so much similarity, the thought process, the problem solving, the creativity, the critical thinking. And now we see what the result of this whole process might be. So the first thing to look at is, now this is scientists like you who have created this enjoyable art. So let's look at this. Which door will the ball hit? Now, I want to ask you, which door do you think the ball is going to hit? Can you predict? One, two, three, four. Which one? Quick, quick. Which
Ma'am,
one?
four.
Huh?
Four.
Four.
I think two.
Ma'am,
Okay.
4.
Two.
Let's.
Two.
Three, ma'am.
Why do you say four? Why do you say four? Let me hear your reasoning.
Ma'am, because there is another ball behind the dominoes. So the red ball will get curved by the banana and it will hit the dominoes. And
Huh.
that's why it will start a chain reaction, because of which the yellow ball will start throwing
Okay.
towards the
Okay.
banana.
Let's see. Okay. So let's see the next one. Now, which one is this going to hit?
Ma'am, three.
Okay, let's see.
Three, ma'am.
Okay, let's see.
Ma'am, 2.
Let's see. This time nobody could guess. Which gift will be uncut? Now this time, which gift will open up? Which one do you say will open up?
Blue one.
Blue one?
Purple one.
Ma'am,
Ma'am,
purple. Purple.
Okay, let's
purple.
Ma'am, yellow.
Ma'am,
Let's
purple.
let's check. Oh. So So do you think you could make this for your school carnival or some for something, some visitors? This art is good, no? You can easily
Yes.
make this one yourself. So much physics there. So now you see something more beautiful and very different. So let's see what this is. So देखो, you can make the motion change forward, backward, just by flick of a hand, whether it is going forward or it can come backward also. So does it raise any question in your mind? Whenever you see something, always think of what is the question that is coming to your mind, because questions are the beginnings of great work anywhere. And I want to ask you one thing, and that is this: does motion need memory? Do you think if we
Yes.
didn't have memory, would we perceive motion?
No,
Why
No,
not?
ma'am.
Why not?
ma'am, because we see
Yes,
motion,
ma'am.
we know whether a certain object has moved from one position to another. So if we don't have a memory of whether it started from one place, we would not know whether it moved at all.
Absolutely. So maybe this is all to do with our memory only. Now, I want to show you how beautifully people have imagined how they can create artwork. So, here is an idea by Aparna Rao. She's saying art that craves your attention. And I'm calling it motion that craves your attention. So, yeah, so just you can read this. So what is did you can you tell me what happened here? Anybody, what did you understand this artwork was?
Ma'am, actually the video got broken, so I couldn't see it properly.
Yeah, so I'll show you again once more the video. So do you get it? These are some panels on the wall, and if a viewer enters the room, they snap to attention, and then when the viewer is for some time in the room, they kind of become relaxed, and when they relax, and then if somebody comes again, they again suddenly snap to attention. So do you want to see this again? See how these are these are 6 7 panels, and as the viewer enters the space, they snap to attention, and if the viewer remains there, they kind of become immune and they become lax, and if they then sense another presence, they will again snap back to attention. So now you see how motion has been used to create a sense of, a sense of emotions, as though these have emotions, and they can sense the presence of a viewer and then change how their behavior is. So So how the art and the science have mixed here together. And then let's see something really beautiful. Doesn't it look breathtaking?
Yes.
Yes, ma'am.
So could you even imagine how much physics might have gone into this? What kind of physics must have been involved? Anything thoughts on that?
Inertia.
Ma'am, dynamics and kinematics.
Okay, so what about what kind of kinematic ideas? Something that you might have done in your studies.
Ma'am, they have to find the exact position and time of each of them, so they use kinematics for that.
Yeah,
Motion of
yes,
fluids,
yes.
fluid mechanics and fluid motion.
Fluid motion, and then if it is free fall, and then how much distance one drop is covering in a particular time, and so another one has to cover how much time, and so that at one moment they are all positioned in space like points in on graph paper, and then at that time suddenly the camera takes a click and it is frozen in time. Then another frame they prepare like that, and then we mix it all together to create the animation. So much kinematics, so much dynamics, so much um, optics, and beautiful, isn't it? Do you think this art form could have been made without the understanding of physics?
No.
No, ma'am.
Right. So physics is amazing. Things it can do itself is amazing, and things that it can do are also amazing. And now look at this. This is an art piece by Alice Lay, and this is a bookshelf. So, can you guess what is maneuverable about this? Why? What is so wonderful about this creation? Can you tell me? Can you
I
guess?
think this is made up of paper.
Okay. What else?
The stable.
What else?
Ma'am, one of the books is connected by a string to it, so probably some mechanism.
You see, when this book by Victor Hugo, Les Miserables, is being brought out, at the top, one flap stands up. You see, the writer's name is here at the top. Can you see my cursor?
Yes.
Yes.
Yes, ma'am.
Yeah. So this
I
flap
know it.
stands up, and then if she keeps it back, the flap will go down. Now tell me, if another book is taken out, can another flap go up?
Yes.
Yes.
Possibly, ma'am.
How can it go up?
By connecting it to a string, like the first.
But then that flap is made to go up only. So how a lower flap will come up?
Ma'am, it might be connected with a different string.
So try creating this. Isn't it beautiful piece of creativity and logic and planning and lot of physics there? So
Yes.
try creating one flap standing up is fine, but can you make different flaps stand up when you take out different books, or you can do it for only one book? That is what I want you to explore. Okay, so this was about force and motion, and then look at this beauty now.
Ma'am, not audible.
Look on the left, Newton on the right, gives you an equation that's really out of sight. Short and sweet, full of hidden delight, and the string goes up and down and down, and the string goes up and down. Hooke and Newton were rivals in the day, but partners for eternity is how they have to stay. Minus kx equals ma, and the string goes up and down and down, and the string goes up and down. Hooke on the left, Newton on the right, gives you an equation that's really out of sight. Short and sweet, full of hidden delight, and the string goes up and down and down, and the string goes up and down.
So did you find it beautiful?
Yes.
So what was surprising here and what was beautiful here? What did you like about it?
They equated spring force and mass into acceleration together.
Uh-huh. So what is the video about actually?
But two scientists fighting for who invented the particular
So one, who are the two scientists?
Ma'am,
Newton and Robert Hooke.
Newton and Robert Hooke.
Yes, and you know, both were rivals and they were great scientists. Hooke was marvelous, he was multi talented. He worked on cells, he worked on the.
Yes, ma'am. Robert Hooke found dead cell.
Yes, ma'am.
Yeah, so they were great rivals, and Robert Hooke was multi talented, but Newton never allowed him to, rise. And till his death, Newton didn't allow even one picture or painting to be made and put anywhere, though he was such a prominent scientist. And only after his death, people made from memory this painting. Now, about this video, what is particularly surprising to you?
Two rivals singing a song.
Is it is that so surprising? Is there any technological surprise here?
AI
Ma'am,
How
about
can
the spring.
the painting move his its eyes and lips? Can a stationary painting
Yes,
move?
ma'am. Ma'am, it is made by AI.
Not AI, it's a software where you, yeah, maybe AI has the role. So even you can do it. You can go to the net and use this software and create movement of lips and eyes in the paintings. And now this is using that feature. And how is it connecting? What is it saying? That even though they were rivals, but they are forever connected. How are they connected? Through what are they connected forever?
Ma'am, their thinking was
The formula of force. Force is equal to minus kx and force is equal to mn.
Right. F equal to minus kx was given by Hooke. That was about the springs. That if you stretch a spring by x amount, then the restoring force, the force with which the spring tries to go back to its original size, is F. That is the restoring force. And on the other hand, Newton gave this formula F equal to ma, which was the second law, right? And there is one system where these formulae come together, and that system is of the spring. So as you stretch the spring, the restoring force increases, and if you release it, the acceleration would be determined by the stretch, because that is what determines the force. But then as the spring goes back to lesser and lesser length, the force reduces and acceleration also goes on reducing. Ultimately, at mean position, the acceleration will become zero. So, like this, in the working of the spring, they are forever united together, even though in real life they were not able to see eye to eye to each other. So, such a beautiful creation. And now, look at this energy
ma'am,
generation.
your screen is not shared.
My screen is not shared. My screen is not shared. Nobody can see my screen.
Yes, ma'am.
Yes, ma'am. You can share it again.
Oh, oh, so
Maybe internet issue.
oh, so why didn't you tell me that? Whenever my screen is not visible, please tell me. Is it visible
Okay,
now?
ma'am. Okay. Yes, ma'am.
Yes.
Perfectly visible.
Yeah. So now look at the energy generation in style. You must have heard that there are generators which generate energy. But then you look at this sun powered generator, which is spherical in shape, and it has been designed by Andre Brussel. So now the world is turning artistic, the scientific world is turning artistic. And on the other side, you have by Elena Parucheva Ondine. So here also, these are wind turbines. You look at the ornament, that necklace that this lady is wearing, and something in her head and something in her hand. All these are turbines or wheels which turn due to the wind, and that generates electricity. So, such gigantic artistic electricity generation. And then another one by Elena only. This is again, it generates electricity. You can see all these wind turbines, but it is in form of a shoe. So, what artistic beauty, and at the same time, so functional. Now, properties of material. In this field, you look at this. Can you guess what this is made of? Can you guess
Layers
what
of
is
paper.
paper?
By
And
paper, ma'am.
what property of paper is it?
I used to be a builder developer back in 2008 when the housing crisis was in its
Ma'am, I
full.
don't think it's a
I
property
lost
of
my
paper
business. I had to
itself.
declare bankruptcy.
Pardon?
Ma'am, I don't think that it's a property of paper itself. Like, I think they layered a lot of papers together and then joined them to make them flexible.
And I had to start again.
True,
I had
true.
to figure out what I was going to do in my life. I was always an artist at heart. I've always incorporated art into everything I did. And eventually, I decided that I wanted, if I was going to make a difference in life and I was going to make a difference so late in my career, that I had to create something totally radical, totally new that no one had ever seen before.
So, do you think you can stretch a single paper like this?
No, ma'am.
But does the property of paper change when they assemble so many together? How the elasticity has been produced by
Yes.
changing, by making it in this kind of combination?
Ma'am, they folded it multiple times. So like when they release the pressure, I think it tries to come back to its original shape, giving it that elasticity feeling.
Exactly. So that is what I'm trying to point out, that how scientists on one hand tweak the properties of materials to create new materials with new properties. And this artist has done what? Taken the paper and assembled it in such a fashion so that it has been given the property of elasticity. See?
In order to create my sculptures, I have to first start gluing sheets of paper into as high as I think my sculptures are going to be, normally about 3 feet. I start to carve, I take away paper by using certain tools that I've developed for this.
And do you know now that paper folding or properties of paper have advanced to such an extent that the scientists at NASA and other places, they are using origami to fold the solar panels in space. Am I audible?
Yes.
Yes, ma'am. Yes, ma'am. Yes, yes.
Yeah. So, how we manipulate the properties of something, that is of interest to scientists as well as artists.
Once I start to take away these paper.
Now, look at this. Isn't it a beautiful artwork by Hilary Waters File?
Yes, ma'am.
Yes, ma'am.
Now, tell
Yes,
me,
ma'am.
would you be able to do this kind of embroidery on every leaf?
No,
No,
ma'am.
ma'am.
Please.
No,
First,
ma'am.
we need to dry the leaf, na.
Draw the leaf. Why? This is not drawn, these are real
Dry,
leaves.
dry, dry.
Dry. Now, are they dried? So, would dry leaf you will be able to assemble and embroider on it like this?
No, ma'am. It will
No,
be
ma'am,
brittle.
they would break if you
It
dried it.
would break. Very right. So, the properties of leaves also change with time. And do you think, uh, even if the leaves are green, like these ones are, can you embroider on every leaf?
No, ma'am,
No.
not every leaf.
No, ma'am.
Why not? Why not?
Ma'am, because they'll have to be thick enough. Because if it's too thin, then it will break apart easily.
Oh, even if it is thick, it may break apart. So, brittleness, does it have to do with thickness always?
Ma'am, it should not be
Ma'am, no.
easily breakable if you want to do embroidery on it.
Right. So, so it must have been a matter of research that which are the leaves where she can take these, which she can take and embroider on. And do you notice embroideries along a particular direction with respect to the leaf? What is that direction? What in the leaf gives it the direction of embroidery? Is there an inherent direction inbuilt in the leaf which is giving, which is informing the embroidery?
The veins, I think.
The venation, yes, the veins. Wonderful. And why do you think venation is required?
Ma'am, to transport materials to different parts of the leaf.
Ma'am,
Now,
for water transportation.
supposing the leaf didn't require any water transportation, would it still need the venation?
Yes, ma'am, I think so.
Yes,
Why
ma'am.
would it need venation?
Ma'am,
To
it's not only
support the
water.
structure.
Support the structure. So why does it need to support the structure all over, everywhere? I mean,
Ma'am,
if the
because
central one would have been fine. The central one, which is the thick one, this one, that would have been fine. Why this, all this, and this, and everywhere does it need any venation?
ma'am, because if it was only on the middle, the stability would only be on the middle. The ends would not have that much stability. They would break off. That would be worse.
Break off. Or what else? Supposing they didn't break off. Supposing the whole thing was continuous only, it wouldn't break off then.
Ma'am, it would not like maintain its shape. It would probably fold and
Okay, so it would not remain flat, it would fold itself maybe, or droop maybe, hang from both sides. But is it important for it not to drop from sides and hold flat?
ma'am,
Yes.
the greater surface area should be exposed to sunlight for photosynthesis.
Yes. So leaves are solar cells, a kind of solar cells which are receiving the sunlight and converting it into something else. So they need a structure which supports themselves, right? The structure needs to support the material. So God is so efficient. The creator is so efficient that जिसको बोलते हैं ना एक तीर से इतने शिकार किए हैं, that with one idea of venation the problem of water transport has been solved. The problem of the structure has been solved, the stability is there, and also the area leaf is open to the sun to receive the sunlight. Maximum area is exposed to sunlight. So what a wonderful creation, and what a wonderful problem solving, and what optimization of efficiency, right? Now look at this. Do you think this could be a temperature record? And this and this, all of them are temperature records. Can you guess how?
Ma'am, maybe the color represents the temperature that day, and
Mm-hmm.
then they can knit it together.
Mm-hmm. And what might these two leaves be representing? See, the color is different.
And maybe the minimum and maximum
Probably an
temperature
evening.
of the day.
Minimum and maximum. So they have probably a color chart where they have temperature ranges assigned to colors are assigned to different temperature ranges, and that's how this is built. Do you think this was also a temperature record? The song or the music that you heard?
Ma'am,
Yes,
there's a
ma'am.
possibility.
Yes, ma'am.
The
Yeah,
different notes correspond to different temperatures, maybe.
different frequencies being assigned to different temperature ranges. So could you feel the heat rising?
Yes.
What made you feel that heat is rising?
The frequency.
Right, the frequency. Now, some artists have tried to depict the thermodynamic variables. So, look at this. Isn't it hilarious?
Yes, ma'am.
It's the pressure that they're trying to represent. So, what are the thermodynamic variables really? Are there any class 12 students here? So in thermodynamics, we have pressure, volume, temperature, entropy, and whatnot. So pressure is one of them. I just loved you to see this. Then we have oscillations and waves. And you know, the first thing that comes to your mind when you think of oscillations is pendulum. So this is the artist Nancy Graves, and this is a pendula series which is inspired by pendulum. So very lovely pieces she has done using thread and cloth and wire, all inspired by pendulum. Now, this is the story of a boy and his atom. And this is the world's smallest movie. And what you will see are really atoms, single atoms. First time this was done in the lab. Each one of this is atoms. IBM research. So these were not ball bearings, these were really atom by atom that it was done. Amazing it looks. Now, what does it look like here in front of you?
It looks like a room.
It looks like a room. But then, is
Mom,
it
there's an
Mom,
upside
it's upside down.
scenery. There's an upside down scenery on the top of a
so,
field.
so do you think it is painted like that?
No, mom.
And it's a projection.
Yes, mom.
It's
It's a
projection.
LED.
How could this projection come there?
By a lens, the images are inverted.
Lens. What else is possible? Okay, lens. What else is possible?
Mom, they use something like a pinhole camera, like the
Haha.
mechanism of it, but expanded.
Actually, this is a pinhole camera. So what they have done is close every small opening with newspapers and black papers, and then in the window they stuck black papers and made just one hole out of which the whole outside scene is projected on the wall. Just imagine on the parents teacher meeting day, you create one room in your school like this. How spectacular it would be, isn't it? And here
Yes.
is a hotel in America which gets which earns out of this phenomena. So this is the spring scenery outside projected upside down on the curtain of the room. Springtime. You can see here these buildings. Uh,
It's like a paint.
yeah, these are buildings here. Okay, and here there is some other feature. And now I'll show you the winter time. Same place. Now see, again same scenery here and same features here, but now it's all drab looking because winters is all white, brown, and black. All colors are gone there. And this room is supposed to be one of the very expensive rooms because it changes view according to the season. And just think how the people have. So, what was the dance about?
When they were
The
depicting
younger self
past
of
and the future
Yes, ma'am.
and the two sides of
Pardon?
the mirror.
Mirror. How
the
do you know?
present and the
Just because the name is written here, mirror dance, is that why you're saying that it was a mirror
It,
dance?
it's supposed
no,
to
ma'am.
depict
Their
the
moves
object
were
is supposed to depict
synchronized.
like a mirror or a window to the past and the future, and
The
the
replication of the
yeah,
movie.
No, but every mirror, if you look into, it doesn't show your past and future. So, what about the dance that told us that it was indeed a mirror dance?
Well,
both
the moves were
replicating
synchronized.
each other's moves.
Pardon?
When they
Allow
were
other people also
Anything,
to speak.
the
Yeah. Yes.
anything that the older boy was doing, and the younger one was doing with the opposite hand, which tells that it is a mirror dance or something like that.
Yes. So, what you are calling lateral inversion.
Yes, ma'am.
Now, does Miller really invert something literally? Left ka right or right ka left karta hai nahi? That's a very debatable point which we can take up in some other workshop or webinar. But the dance was beautiful, and we knew that it was a mirror dance because of that actions which were, the way we see in mirrors, in actual mirrors, right? So beautifully depicted. Now let's see the artists in electricity. So look at this. Does it look like a concert scene?
Yes.
Yes, ma'am.
It's
And
made
what are
of the LED bulb.
the waste
They
material?
used
Yes,
resistors.
ma'am. LEDs and resistors.
Resistance, LEDs, and small capacitors. These are small ceramic capacitors, and these are big electrolytic capacitors, and these are also big electrolytic capacitors. These drums also. So in your school you must have been having a junkyard of old exhibits which people made, or electronic things which nobody is using now. Now these waste components can be taken out and made into such beautiful art pieces, and then have an exhibition of that. And this idea is utilized, see here, by Julie Alice Chappell. How beautifully she has created this butterfly. See, these are all old PCBs which she buys from the junkyard with all the ICs and components already fitted there. She cleans them up and puts some more here. And then this is a special fabric that she's used. And each piece sells for not less than $100. Some of the pieces are $2,000. So the money is in creating something new, which people want to buy, or it is in creating something which is useful for somebody. It makes somebody's life easier. It makes somebody's work lighter, makes the work process faster and more efficient, more pleasurable. So people will pay money for that. And that is why we must think in different ways. Who could think that out of the waste such a beautiful and such a delicate thing could be created out of such a solid, horrible looking wastage? Isn't it?
Yes.
and then this will floor you. This is something beautiful. So, wasn't it beautiful?
Yes, ma'am.
The imagination of the artist and the science and the engineering and technology creating such beauty, breathtaking, absolutely breathtaking. And then look at this. What does it look like to you?
In some kind of powder.
Some kind of powder in which
They've made a design.
there is a design. So, this is white sand in which a design is created, and every moment the design keeps changing. And read this. This is done by Sisyphus machines, which are X ray coordinate devices, and they use magnets and motorized arms to move metal balls precisely over a garden of sand. Computer programs control the patterns carved through the plate, creating stunning patterns and intricate loops and swirls, all at a meditative speed. Now, if you see carefully, do you see one tiny ball here and another tiny ball here and another tiny ball
Yes, ma'am.
here? So these are steel or metal balls which move in this fine sand, white sand, to create these engravings and these patterns. and what controls their movement is a magnet below, and the movement of that magnet is programmed, and therefore the programming is of the xy coordinates of those magnets. And so I'll show you in the next slide how this happens. See, this is time lapsed. In 12 hours, all these patterns, and you can see those tiny balls moving and how their movement is creating these beautiful patterns. So marvelous.
Ma'am, I've seen machines like that on the internet, and a lot of people use it as a as a symbolism for how time heals everything most of the time.
Yeah, so we will not go into healing or anything here. We are only looking at how scientific ideas are creating beautiful art. And can you also do something? Maybe take a glass plate and put suji over it and put one ball bearing above, and from below you move a magnet. And when you move the magnet, the ball bearing moves on the semolina suji and creates some pattern. Yeah. Now look at this one. It's ugly and scary, but then uh, it's a scientific marvel, no? How do you think, what were the materials that were used?
It was probably a magnetic fluid.
Yes, ferrofluid or something like that. And so, how did it rise suddenly? I mean, why didn't it rise earlier, and how it's rising suddenly and then falling back?
Ma'am, it
Maybe
could have been due to
electromagnets.
an electromagnet. We can
Yes,
control when it.
yes, you get the idea. Very good. And then I'm going forward. Now, this is the last beauty. Whoever thought of a paper dancing? But here is the paper dancing. Did you love this?
Yes.
So how could have anyone even thought that paper can dance? But see the idea in an artist's mind and how it has taken shape. So so what all has gone into it? Can you tell me?
Ma'am, I think there were like magnets in the feet of the origami.
Hmm. They might be these might be magnets or these might be metal piece and the magnets might be underneath something like that, and then they've been
Yeah.
again the movement has been programmed according to the music, right? So that's all from my side. I hope you enjoyed the program today.
Yes,
uh,
ma'am.
Yes, ma'am.
have I stopped
So,
sharing? Yes.
yes, now we are moving forward this the Q&A session.